All right, the instructions in this video say write the following numbers using a different notation. These two numbers are written in scientific notation, and these two numbers are written in standard notation. So what we're going to do is we're going to write these two in standard notation, which just means regular numbers, some with decimals, some without. And then we're going to practice writing these in scientific notation. I recommend that if you're just using this video for practice, pause it at this time, try them on your own, then you can watch the video all the way through or skip to the very end and check your answers, however you want to do it. If you did get the questions wrong, though, please go back and watch the video for that portion. I will make sure I go over each one as clearly and concisely as I possibly can to eliminate any errors. So I've got the four different kinds here. I have one with a positive exponent, one with a negative exponent. Then I have an extremely tiny number and then a very big number. So we're gonna treat them all a little bit differently. First, I'm going to start with writing 3.04 down. I'm going to do this first problem. A -5 indicates I have to go to the left when moving my decimal. That's how a lot of people like to think of it, but a lot of people get confused, left and right, positive, negative. Some people like to remember that when you move to the left, that's where the negative numbers are located on the number line. And that's fine too, but once you're converting it back the other way, it can get kind of confusing and you mix things up. So here's how I like to think of it. Negative exponents means small numbers. Small numbers, in order to make this a smaller number, you're going to want to move it to the left and move your decimal further to the left to create that smaller number. So that's what I'm going to do. I'm going to move it over 5 spaces, and there's going to be a number in each dip, and you'll see what I'm talking about here. So we have 1, there's where my 3 is, 2, 3, 4, 5. This is where my new decimal is going to be. So as you can see, the 3 is in here, located in this little dip. I like to think of it as the waves of the ocean. If you have the waves of the ocean, you're going to have a lightsaber between each wave. Excuse my messy handwriting. It's difficult to write on this iPad sometimes. So those are all zeros, and this is where our new decimal is going to be. So the correct final answer for that one is 0. And then you see we have 4 zeros here. 1, 2, 3, 4, and then 304. So that's my final answer for the first one. So the negative indicates we're going to have a smaller number, smaller than 1, and this is just the work I kind of showed you there. The same exact thing here, except you'll notice the one big difference is that 5, it's a positive. So that means we're going to be going to the right for this example. So I'm going to try to make my work a little bit more neat here as I practice writing on here. I'm going to move my decimal to the right 5 places. So 1, 2, 3, 4, 5. So this is where my new decimal is going to be. And in each of these little dips, I'm going to put a 0 because there's nothing there. That's going to give me 304. 0, 0, 0. And if you want to, you could put a comma in there to make it easier. That's 304,000. That's what we get here. So a big exponent indicates we're going to have a bigger number. And if you remember, to the right of a number line, that's where the positive numbers are, that's where the bigger numbers are. It gets a little bit backwards when you go here as far as your left and right go. So I like to stick with the big number, small number rule that I've been discussing. A small number indicates you use a negative exponent, and a big number indicates you use a big exponent. It's just the way I've always learned it, and that's, for me, the easiest to remember. So for this next example, I'm just going to write directly onto the problem. Here is where my decimal currently is. Your goal is to always create a 1-digit number, because scientific notation is always written as 1 digit plus a decimal afterwards, but it's always 1 digit. It's 1 point something, 2 point something. Real true scientific notation is never 10 point something, 11 point something. That's not right. Usually those answers you have to rearrange to put in correct scientific notation. So our goal is to get a 1-digit number, so we're going to move our decimal to this location here between the 4 and the 6 to get 4.67. So that'll be part of my final answer, 4.67 times 10 to the something. Don't know yet. I'm about to work on it now. So I'm going to take this decimal, I'm going to move it 1, 2, 3. I'm going to move it over 3 places, but remember, this is a small number. It's very tiny. It's less than 1. So I'm going to make that a negative 3 exponent. Then this will be my final answer for that problem. Last but not least, we have our number 26,000. We are going to assume anytime you have a whole number like this, you can't see a decimal. But decimals, whenever you have a whole number, always go at the very end. So I'm going to put that right here just to give me a mental picture. And remember, again, we need a 1-digit number. So if you ignore all these zeros, you look, the only numbers you really have are the 2 and the 6. In order to make this a 1-digit number, you have to put the decimal in between the 2 and the 6. So my final answer should include 2.6 times 10 to the something. Don't know it yet. So this is where my decimal currently is, and this is where I want it to go. So I'm going to count 1, 2, 3, 4. So I'm going to have an exponent of 4. I'm going to keep it a positive because 26,000 is a large number. It is bigger than 1. I hope you have found this video helpful. For my students, if you could please shoot me a message on Edmodo and let me know if you need more problems done. I'd be happy to make a follow-up video.